Alright, in this video, we are going to look at solving algebraic equations. We're going to look at simple one-step, two-step algebraic equations and how to solve them. Alright, so the idea again of an equation is that it's a question of balance. Again, I would like to picture this idea of a balance when you're thinking about equations. Here we have an example. We have an ellipse, we have some squares on the left side, we have some squares on the right side, and we can easily count those squares. We can count the squares on the right side as well. And then but we don't know how many squares the ellipse is worth. We can think of these as blocks or pounds or kilograms or whatever we want, but we know that we have 6 on the left side and we have 11 on the right side. And this ellipse represents another amount that actually balances out these 11 squares on this side. So in an equation, two amounts on a balance scale must be equal to each other. That's what it means to be equal. An equation, that's what we call it, an equation. All right? So our question is, well, what does this ellipse weigh? Right? Well, we can kind of look at this and think about this in our head and kind of look at that and go, well, I got 11 over here, I've got 6 over here, well, how many more do I need to make that 11? And you probably can set to this in your head and maybe go, oh, well, I need 5 more. All right, but let's demonstrate this using algebra language. We can write this as E, which represents the ellipse, plus the 6 that we know, and that's equal to the 11 on the right side. And we know that those balance out because the scale shows us being balanced. All right? But we want to take away, if we take away those 6, go back here a second, if we take away those 6, there we go, there's the animation that I'm looking for. If we take away those 6, we can see that, oh, the ellipse is equal to the 5 that are left on the right side. And you can probably do that in your head. That's probably something pretty simple. But the idea is still there, that we take away what we don't need. We remove what we don't need from the side of the unknown amount. This ellipse was the unknown amount. We removed what we didn't need. And to keep it balanced, we had to do the same thing to the other side. All right. So here's the idea of solving an equation. Solving an equation means to find every number that makes the equation true. And we do this by adding, subtracting, multiplying, or dividing to both sides of the equation. Always keeping it balanced. Very important to do that. Okay. So in this equation, let's try another example here. X plus 7 equals 15. 7 added to a number gives 15. So again, solving the equation means find every value of the variable that makes the equation true. And again, this is probably one you can think about, maybe even do in your head. This one's not too difficult. Okay. Let's go back to the balance for this one. Okay. Let's imagine x plus 7 on the left side and 15 on the right side of the balance, and we know since they're equal, they balance each other out. But we don't want that 7 on that side. We want to get rid of it. We want to remove it and just find out what is that x all by itself. So let's take away that 7 from both sides. Let's take that away. All right? And if we do that, take away that 7, and we simplify both sides, we get x on the left side and 15 minus 7, which gives us 8 on the right side. And now we know the value of x. We actually can show those steps. All right, let's write this down algebraically so we can, using the language of algebra, we'll write it down like this. X plus 7 equals 15. The next line, we would write x plus 7 minus 7 and 15 minus 7. We write it out like that, showing our steps. Simplify, we get x is equal to 8. And that is how we would show the steps to get to our solution and prove that the answer is indeed 8. Well, one of the questions people always ask was, how can you do this? How do you know you can actually just add something to the other side or subtract something from the other side? Well, in mathematics, there's this thing called properties of equality, and they allow us to balance equations. using the language of math, here we go. Here we have these 4 different properties of equality: addition, subtraction, multiplication, and division. And basically these properties say that as long as you are doing the same thing to both sides, you're not going to change the value of your result. You're changing things by the same amount on both sides. If you add 1 to both sides, subtract 1 to both sides, multiply by 1 to both sides, or multiply by 2 if you want to get a bigger number, divide by 2, divide by 1. As long as you're doing the same thing to both sides, it doesn't change your result. These are called the properties of equality. All right, let's do another example. Example number 1. We're going to go through lots of examples here today. R plus 16 equals negative 7. I'll throw in a negative number in here for you. All right. Remember, think of this as a balance. Right? Always have that in your mind as a balance. And whatever you do to one side, you got to do to the other side. All right. So let's go ahead and solve this. We need to get the variable by itself. So it's very important to make a plan. As equations get more complicated, a plan is even more essential. What number's on the same side as the R? Okay, that would be the 16. Right? That's the number we're going to want. We want to remove. To get R by itself, we have to undo that plus 16. And so what's the opposite of add 16, or the inverse of add 16 is subtract 16. So that's what we need to do. We're going to make a plan. And here's how I like to show solving equations. I like to draw a line to separate the left and the right sides. I'm pretty messy with my handwriting. I'm using blue lines, and we'll call this the river. And that's the language I'll be using throughout the lesson here. Okay, and let's do our plan. Let's subtract 16 from both sides. I like to write it underneath. I know on the other slide it was next to it, but I like to write it underneath. I think it's easier for me, at least, when I'm writing things down. Subtract 16. Simplify both sides vertically. That 16 minus 16 becomes 0. We don't have to write it. It disappears from the left side, and we're left with just the R. And negative 7 minus 16 gives us a negative 23 right there. The nice thing about algebraic equations is that you can check your solution by putting it back into the problem. Right? If we put negative 23 back in for R, do we indeed get negative 7? If we check, we sure do. So we know we got the right answer. All right. In some equations, the solution may be easy or obvious, as in these ones. Maybe you can even do them in your head. Right? Simply you work the operations backwards and you get the answers. These ones aren't so bad. However, in other equations, the answer is not so obvious, not so easy to do in your head. Decimals, fractions, negative numbers, not as easily to do in your head. However, the steps are the same, right? As long as you can figure out what steps you need to do, you can always get the correct answer. Let's take a look at these ones. So if we have x plus 127 equals negative 93, if we do the inverse operations, since the inverse of adding is subtracting, we just subtract the 127 and simplify, and we get our solution. For the second problem, the inverse of subtracting is adding. If we just add that 3.2 back on, I don't want w minus 3.2, I want w the whole thing. So I got to add that 3.2 back onto my problem, and we get our result. If you happen to have fractions, well, I don't want 2/5 of p. I don't want 2/5 of a pizza. I want the whole pizza. So the inverse of multiplying by 2/5 is multiplying by 5/2 for this example. So if I multiply both sides by 5/2, I get that whole pizza, that whole p back. And as long as I do it to the other side as well, I can get my result. And I find out that p is equal to 15/8. The inverse of multiplication is division. So for this one, a little bit simpler than the fraction one, we get our result. So same exact steps as the more basic ones. Just looks a little more complicated because we got negatives and fractions and decimals going on, but it's the same basic idea. So what do you think about this one? Solve x plus 2 equals negative 3. To get the variable by itself, what would be your first step? If you chose B, you would be correct. Subtract 2 from both sides. Now, the properties of equality allow us to solve algebraic equations by using inverse operations. This chart, I've kind of summarized some of the strategies you need depending on what you see in the problem. If you see one of these in an algebraic equation, you're going to use these inverse operations. Okay, let's take a look at them. If you see addition, you'll use subtraction. If you see subtraction, you'll use addition. If you see multiplication, you use division. If you see division, you use multiplication. If you see multiplication by fractions, you would use the reciprocal fraction, like in the example we did before. If you have equations that have exponents and powers, you would use roots and radicals, like the square root undoes square. If you have roots and radicals, you'll use exponentials and powers. Fractions with unlike denominators. You can use the LCD of the fractions. We'll get into that one later. Grouping symbols, parentheses, and brackets. Ooh, that's some fun stuff. We'll get into that later as well. Lots of good stuff. All right, let's try a couple examples here. Example 2, solve this. X plus 2 equals negative 3. Well, let's draw that river line. Take our plan of subtracting 2. Simplify. We get x is negative 5. Let's check it, make sure it works. Sure enough, it does. So since you can check on homework and tests, you can always check your work. There's no reason to miss a problem. Let's try a few more here. How about this one? If you chose B, m equals 11, you are correct. Okay, let's look at the steps for that one now. Again, draw the river to separate the left and right sides. Add 3 to both sides, since that's the same. We have minus 3 on the side with the m. We want to undo that. We want to get rid of that. We need to add that 3 back onto the m. And we find out 11 is equal to m. Let's check it, make sure we're right. Indeed we are. Okay, what if we have double signs in problems? For example, like plus and minus. We have y plus negative 3. Well, one thing we can do to simplify is rewrite the double signs. A plus minus can be rewritten as a minus 3, or as a minus. How about a minus minus? That we can rewrite that as a plus. So we want to simplify before we start doing our steps, because it makes it a lot easier. Okay. If we have this problem, y plus negative 3 equals 7. Okay. Plan, we want to eliminate our double signs there. Rewrite this as minus 3. And add 3 to both sides. Check our answer. We're good. Okay. Example number 5. Again. Make a plan. Eliminate our double sign. Subtract 2 from both sides. Simplify vertically there, and we get an answer. However, we're not quite done with this one yet, because x is still not technically alone. And what we have there, we have minus x, so the opposite of x equals negative 1. If the opposite of x equals negative 1, what would x be equal to? Well, x would then be equal to positive 1. And we can check to make sure that we've got it right. Let's do one more. What would this one be? Pause the video if you need to. If you chose D, y equals negative 4, you are correct. All right, we'll pause there. Continue this in the next video.